Hello, welcome to helpyoumath.com. Today we are going to compare basic integration method and use substitution method. Let's look at our problems right here. First problem we have is 2x plus 3 to the second power. The second problem is going to be harder because the power changed to be 2020. So let's work on the first one. Since I have a square, I may think about I want to use basic integration method, which is when we have x to the nth power well, n is not 81, so we can follow to get x to n plus 1 over n plus 1 plus a c. In order to use this, our base must be x. However, our base right here from our problem is 2x plus 3. We are not able to use x to the nth dx formula right here right away. So for basic integration method, we are trying to simplify or reduce or expand the expression in order to have x to the nth power terms. So we are able to use the formula right here to solve it. Right, so if we look at a 2x plus 3, it's not hard to expand this because it's a perfect square. We can use the formula, or we can just do 2x plus 3 times 2x plus 3. So if we do that, we're gonna get 4x squared plus 12x plus 9. By the basic integration rules, we are able to do integration for each terms because we have adding right here. Constant number, by the basic integration rule, we can put in front. Right, if you look at right now, the first term we have x squared. That's good for this formula right here. The second one is x by itself. It's good. The last one is a constant number 9, which we can consider we have x to the 0 power. All right, so now we can finish this by using the basic integration rule. That's going to be 4 times x squared becomes x to the 3rd over 3 plus 12 x squared over 2 plus 9, that's going to be 9x plus a c. So it's not very hard to solve this. However, if we want to apply the basic integration for my second problem, that's not going to be easy because our exponent right here is 2020. That's a huge number. Expanding this expression is going to be hard. Now let's think about use substitution method. Right, so use substitution method is we're gonna define something to be u. It's your choice to choose what's gonna be your u. So here I'm gonna pick 2x plus 3 to be my u. The reason I'm doing that because I'm thinking about to have u squared du. Right, if you have u squared du, I basically back to this formula right here. So after I define the u, we have to get a du because we have to change all x. So one x we have is 2x plus 3. We also have to change dx to be du. Right, so in order to change dx to be du, we have to take a derivative of the definition of our u right now. So I take a derivative on both sides. So u becomes du, and 2x becomes 2 dx. Derivative of 3 will be 0, so we don't have to write it. Now we are going to substitute my u back to the original function. Right, so we're going to divide it by 2 right here. So I'm going to substitute du over 2 for my dx. Now let's do the substitution here. So I'm going to substitute u to replace 2x plus 3. That's going to be u squared. I'm going to replace dx by du over 2. That's going to be du over 2. Let's rewrite. So I'm going to put a half in front. So I'm going to have u squared du. So that's a very easy problem to solve. So that's going to be u to the third over 3 plus c. We didn't finish this problem because we changed the variable. Our original problem is for x. So in order to finish this, we have to substitute x back to the u. So we're going to substitute 2x plus 3 back to the u. So that's right now we're going to have 2x plus 3 to the third over 3 plus c. If you want to try to expand this term right here, you should get exactly the same answer. Now let's look at our second problem right here. Second problem, basic integration is going to be hard, but that may be not hard for my u substitution method because the only change is the exponent. We can still have my u to be 2x plus 3. So the change of my exponent will not affect the square I had before, right? It's basically the same. So the only thing we have to do is still we have to get a du, which is 2dx. So now I have my du over 2 equals to dx. So now we do the substitution again. So my u will be still 2x plus 3, and my exponent now is 20. You can see that everything else is the same. We follow the same step as doing the problem by the first one by using the u substitution. So after that, we're gonna do the same step. So now you can easily to solve this and follow the same method we did from the first problem to finish the larger exponent we have right here. So now you see the difference between the basic integration and the u substitution. So u substitution help us to solve some very large exponent right here or some very complicated problem in the future we're gonna have. So now you understand how to use the u. So u gonna help us to get rid of or replace some of the terms. So in the future, you have to learn more about how to use the u substitution. Thank you for watching.